Hello everybody, a very good evening. Let me know if the audio is clear. Hello everybody, a very good evening. I can hear my audio very properly and I can see some people online. So you guys can say good evening or something once you're online here. Hello. So good evening all. Could you just put good evening or something in the chat? I can see some people in the chat already. Okay, fine. Let me start the class here. So in yesterday's class, we started with this question. I told that we will start solving questions on the stresses in beams here. And regarding the stresses in beams, we started with this particular formula. So we checked all the questions and we started with this particular question, not the formula, but actually the question. So if you see that in this question, which is simply supported beam with a uniformly distributed load. So simply supported beam with uniformly distributed load. So we have this Q value, we have this L value. Q value is in kilonewtons. So what you need to do is we need to convert this into SI units. So 1.5 kilonewton is 1.5 into 10 cube Newton per meter. So this is 1500 Newton per meter here. I already told you I gave the derivation also that this value of I already told you that this value of I request you guys to say good evening or something in the chat here so that I can understand that you guys are online. So Q value is 1500, L value is equal to 6. We can substitute and get the value of bending moment, maximum bending moment. So we can substitute that. So first question, if you take it, bending moment max is equal to Q L square by 8. So Q value is equal to 1500. L value is equal to 6 whole square by 8. So we are substituting in SI units here. You will get the value of bending moment as Newton's meter, right? And in this question, they're giving us the answer in kilonewton meter, right? So this means 1500 into 6 square by 8 by 10 power 3 kilonewton meter because we need to put in kilos. So 1500 into 36 by 8 into 1000. So 8 4s are 36 and this gives us that is 1.4. 15 4 is 60, so 1.4 into 4 is 6. So 6 kilonewton meter is the value of maximum bending moment. Is it right? Or something else is there? 36. Q is equal to 1500. L is equal to 636. 1.5 into 4 is coming out to be 6. Why it's coming out to 6 and it is actually 6.5? QL square by 8 is the value of bending moment. Why it is not 6.75? Could you guys tell me what's the mistake I'm doing? Because some people already got the correct answer for this question. Mm, Q 1500 L square by 8 by 1000 1.5 into 36 15 force 60 6 kilonewton meter. I'm getting 6 and here it should be 6.75 1500 QL square by 8. Is this the formula correct? Let me check that. So for uniformly distributed load, yes, it is QL square by 8, right? QL square by 8 only. When you substitute M value, L value as L by 2, so here if you QL square by 4 minus Q by 2 into L square by 4. So it is QL square by 8 only, right? Okay, it is not 4 exactly. So 2 fours are 8, 2 18, 2 twos, 2 9. So this is actually 4.5. So 1.5 into 4.5. 1.5 into 4.5 is coming out to be 6.75. So yeah, simple mistake, but I believe you guys will not do in the examination. 6.75 kilonewton meter. Fine, guys, this is done. Okay, so we got the value as on option number B. Now, could you guys tell me what is the answer for this question? We need to get maximum value bending moment. I don't see any comments in the chat here. Maybe there's a problem with my phone. I'm opening the app once again. Tell me what's the answer you're getting for the bending stress. There are some ads running here. Could you guys comment in the chat here? Okay, fine. I'm giving some time here. I'm giving some time to you guys. So please solve this question and get the answer for bending stress. So you guys know what to do. Yeah, I can see the comments now. A very good evening, Vicky. So please proceed to solve the next part of this question, that is evaluating the value of bending stress. So okay guys, I hope you guys tried this. Okay, so let me give the answer. So we are going to apply the formula which we studied in this question. A formula ఏంటి అని అంటే bending stress formula, that is we know sigma by y is equal to m by I. ఇక్కడ sign తో సంబంధం లేదు, అవసరం లేదు. ఎందుకనంటే ఈ క్వశ్చన్ లో డైరెక్ట్లీ దే ఆర్ ఆస్కింగ్ అబౌట్ ది magnitude of bending stress, not the compression or elongation. ఓకేనా? సో if you see the geometry, it is given that it's a cylindrical rod. So cylindrical rod with some diameter. So diameter is equal to 75 millimeters, right? So this will be the neutral axis. I value is nothing but pi d power 4 by 64. Okay. Y value, you know, sigma is proportional to y. Sigma proportional to y. So ఎంత దూరం వెళ్తే న్యూట్రల్ యాక్సిస్ నుంచి అంత. So this is the value of y max, which is nothing but r, or which is equal to d by 2. So y is equal to d by 2. So at the extreme points, we'll be having maximum value of bending stress. Bending moment value, which we already got, 6.75 kilo Newton meter. So sigma y m I, all these things here. Okay. So now we can get the value of sigma, which is my by I. First of all, let's substitute the value of y and I and remove these unnecessary extra uh, d's. So m into d by 2 into 64 by pi d power of 4. So this d will go, d cube is there, 2 will go, 32. So you will get sigma value as 32 m by pi d cube. Now let's substitute the values. 32 into 6.75 into 10 cube by pi into d value. So d value is 75 millimeters here. So 0.075 whole power of 3 Pascal, because SI unit is Pascal here, you will get like this. So now if you simplify this, 32 into 6.75 into, so 216 into 10 cube by 32 into 6.75 into 10 cube by, and the denominator we have 0.001324. Okay, so if you simplify this, 216,000 divided by 0.001324, and it is coming in Pascal. So to get in megapascal, what we need to do is 0.001324 into 10 power of 6, because we need to get in megapascal, right? Because options are in megapascal. It is coming out to be 163.141 megapascal. So which is 163.141 megapascal, which is this one here, approximately option number A. Fine guys. So ఈ క్వశ్చన్ తో మీకు ఈ యొక్క బెండింగ్ స్ట్రెస్ ఫార్ములా ఎలా అప్లై చేయాలి అనేది మీకు తెలిసింది అనుకుంటున్నాను అనమాట. ఫైన్, క్లియర్? యా, ఐ కెన్ సీ ద కమెంట్స్ నౌ. రసజ్ఞ, శేఖర్, Vicky give the answer here. So all the three people in the class gave the answer. So option is option number A. Very good. You guys are following this. Now let's proceed to the next question. So take this question. ఓకేనా? ఎందుకంటే ఈ క్వశ్చన్ గేట్ దైనా కూడా మీరు ఈజీగా సాల్వ్ చేయొచ్చు. సో వాట్ యూ గైస్ కెన్ డూ ఈజ్ లైక్ టేక్ దిస్ అండ్ apply all the values and get the answer for this question and take care of the units here. Okay everyone, clear? Do it. Let me see if you guys have given any of the answer for this question. Vicky, Rasagna are saying the answer to be 30 megapascal. Let me see if anything is written in the notes. No. Yeah, but I think it's a correct answer only because all of you guys are getting the same answer. Okay, let me solve this. It is the similar type of question, but the thing is, it is actually not a cylindrical one. It's having cross section of rectangle, width is 100 millimeters, height is 200 millimeters here, length is 4 meters, load intensity is 10 kilonewton per meter, and we need to get maximum bending stress. Fine. Let's go step by step here. So let's take the data given in the question. So the beam is like this. So this is B, this is H. So B value width is equal to 100 millimeters. This H value is equal to 200 millimeters. Length is equal to 4 meters. And the load intensity Q is equal to 10 kilonewton per meter. All the formulas we have seen already. So we have bending moment max is equal to Q L square by 8, right? We need to get maximum bending stress. Bending stress will be maximum where bending moment is maximum. So we need to get first of all maximum bending moment. So QL square by 8. Q is 10 into 10Q. L value is equal to 4 square by 8 here. So 4, 16 by 8. If you simplify this, we are getting this to be 20,000 Newton meter or 20 kilonewton meter. So now for sigma is equal to my by I. So for this rectangular cross section, this value is equal to 100 millimeters. This H value is equal to 200. Okay. So Y value will be this one, which is equal to H by 2. And you know the value of I is equal to BH cube by 12. Sigma is equal to M. Y is equal to H by 2. I is equal to BH cube by 12. M into H by 2 into 12 by BH cube. It is 6M by BH square. Substituting that, M is equal to 20 into 10 cube by B value, which is 0.1. I'm directly putting in SI units, which is 0.1. H value is equal to 0.2. 0.2 whole square. So the value of sigma comes out to be 120 into 10 cube by 10 power of minus 1 into 4 into 10 power of minus 2, because it is 2 into 10 power of minus 1, right? So if you simplify this 10 power of minus 2 into 10 power of minus 1, that is 10 power of minus 3, 10 power of minus 3 into 10 power of minus 10 power of 6 by 4, which comes out to be 30 into 10 power of 6 Pascal, which is 30 megapascal. Your answer for this question that it is 30 megapascal is absolutely right. Fine, guys. So that's how you need to apply the formulas and get the answer. So very good, everyone. Almost everyone in the class got the correct answer here. Now this one, I hope it is very much straightforward. So we need to understand that EI value is given the name as flexural rigidity. Okay, flexural rigidity or flexural stiffness basically. Understood? So the answer for this question is fourth option. So please write in the chat that screenshot taken, sir, for this fourth question. I mean this question. So I hope you guys have taken screenshot of this question. It's easy question. Easy questions are pretty much easy. Okay. So this question. So I'll give you some time. How you need to understand how we are getting this. Okay, this question is from shear stresses. We'll discuss that later. The shear stress question, we'll discuss that later, how it is coming constant and everything. But you can tell easily as well because shear stress depends on shear force. So if you take a cantilever beam expecting or experiencing a point load at the free end, so that has a shear force which is constant, right, throughout the length. So shear stress along the beam or along the length of the beam is also a constant actually. Fine. So you have this one here. This you can say very straightforwardly. Flexural rigidity or flexural stiffness is given the answer as. Could you guys type answer for this question? 3 minutes. Just everyone type answer for this question. So I hope you guys might have understood that for this question the answer is option number one because you guys already know flexural rigidity is nothing but E into I. Okay, this question is also done. And this question here, so we'll discuss these. These questions came, this concept of pure bending also I'll discuss little later. Okay, and cantilever beam carrying concentrated load at the free end, the maximum stress due to bending in not exceed 120. Yes, come on, please do this. So you're going to apply this concept on some other type of loading here. So please take your time and I'm showing you the answer to be fourth option, 80 millimeters. Please get the answer. Come on, everybody. So I'll give some more time to get the answer for this question. If you got the answer for this question, please put in the chat. Got the answer, sir. Answer is also written here. That answer is option number 4. Come on, guys. So, okay, guys, I'll solve this question. So, I believe you guys got the answer, or otherwise, you continue trying, you'll be definitely getting the answer. So, in this question, they are saying it's a steel cantilever 2 meter long. So, let's take the data parallelly. So, it is given in the question that length is equal to 2 meters. Concentrated load of 3 kilonewton is there. So, it's a cantilever beam with P or load is equal to 3 kilonewton. So load W is equal to 3 kilonewton here. If the maximum stress due to bending is not to exceed 120 megapascal or Newton per millimeter square. So we need to understand sigma should be less than or equal to 120 Newton per millimeter square. You can think that how I am telling 120 Newton per millimeter square is equal to megapascal. That is how it is because 1 Newton per meter square is equal to 1 Pascal. ఓకే ఇప్పుడు మీటర్ని మిల్లీమీటర్స్లో రాయండి ఓకేనా సో మీటర్ని మిల్లీమీటర్స్లో రాస్తే దట్ మీన్స్ ఇక్కడ ఏమవుతుంది మనం ఏం చేస్తున్నాం ఒక్కొక్క మీటర్ని 1000తో డివైడ్ చేస్తాం అనమాట సో 10 పవర్ 3 10 పవర్ 3 this is equal to Newton by 10 power 3 millimeter square. Fine. Is it right? 10 power 6 actually. Yes, because 1 millimeter is equal to 1 millimeter to 10 power of minus 3 meters basically. Right? So 1 millimeter square is equal to 10 power of minus 6 meter square. So 1 meter square can be written as 10 power of 6 millimeter square. Okay, so from this we are writing like this 10 power of 6 millimeter square. So 1 Newton per meter square is equal to 1 Newton per meter square is equal to 10 power like this Newton per 10 power of 6 millimeter square. This implies 1 Newton per millimeter square is equal to 10 power of 6 Newton per meter square. Okay, so this sigma less than or equal to 120 into 10 power of 6 Newton per meter square. Sigma should be less than or equal to 120 10 power of 6 Pascal, or like you can take it as megapascal basically. So sigma value is less than or equal to 120 megapascal. That's the thing here. Remaining thing, if you take it, the cross section of the beam is circular. So the beam is like this. It's a circular one. So we can write down y value is equal to d by 2, I value is equal to pi d power of 4 by 64. So we need to get the diameter. So if you see, for this cantilever beam, is equal to W into L. So W value is equal to 3 kilonewton into L value is equal to 2 meters, is equal to 6 kilonewton meter. Okay, so substitute in that sigma by y is equal to m by I. This implies sigma is equal to my by I. Sigma is equal to m into y d by 2 by I is equal to pi d power 4 by 64. You'll get sigma is equal to 32 m by pi d cube, which should be less than or 120 megapascal, or 120 into 10 power of 6 pascal, or Newton per meter square, which is the SI units here. Okay, now let's substitute all the values to get the value of D. M value is 6 kilonewton meter. 6000 Newton meter is the value for M. Pi into D cube less than or equal to 120 into 10 power 6. Okay, so we can write down from here that D cube, according to this, D cube will go that side, should be greater than or equal to 32 into 6000 by pi into 120 into 10 power 6. If you need to simplify, this 3 will go, 10 power 3 will come here, 6 will go, 20. Okay, this 0 will go and you can write down 4, and 2 will go and there is 16. So you'll have d cube greater than or equal to 16 by pi into 10 power of 4 in the denominator. Right? If you simplify this, let me put in the calculator and understand. So this is 5.095 into 10 power of minus 4. We need to get d, right? So d should be greater than or equal to, it is coming out to be 0.0798 meters. That means d should be greater than or equal to 79.8 millimeters. Right? 79.8 can be approximately taken as 80 millimeters. That's how we are getting the answer to be fourth option. Fine guys, అర్థమైంది కదా? సో మొత్తం మ్యాథమెటిక్స్ అంటే ప్రీవియస్ చాప్టర్లో క్వశ్చన్స్ లాగా టఫ్గా ఏం లేవు. యూ జస్ట్ నీడ్ టు బి వెరీ క్లియర్ వాట్ యూ నీడ్ టు గెట్ హియర్. Fine. Ganesh Jogu, I think I'm meeting you after some time, a little long time here. So using this formula, you'll be getting the answer like this. Clear? Fine, everyone. Okay. This one you can easily say sigma by y is equal to m by is equal to e by r, and there is nothing but option number. Sigma is shown in terms of f here. The option number 1 here. Okay. Clear? Understood? And I will tell you about these questions a little later. But before that, I would like to tell you the concept of pure bending, and then I will stop this class. This completes half of this chapter. We will dedicate the remaining time. I mean, tomorrow's class, or tomorrow will not be having the class. Um, we'll let you know about the next class. It may be there on the uh, Sunday, or it might not be there on Sunday as well. So what you need to understand is basically uh, pure bending means bending moment will be constant, and I already told you pure bending means bending moment is basically constant. Other thing is, we know shear force is equal to dm by dx, right? Slope of bending moment diagram is equal to shear force, right? When you say bending moment is constant, this implies V is equal to dm by dx is equal to 0. So V value is equal to 0 here. So you need to understand that in the case of pure bending, you'll observe that bending moment is constant, and that gives us the result that shear force value is equal to 0 here. You need to be very, very sure about that one. Clear, guys? Understood? So if you see the questions, let's go back and see if any questions are there based on pure bending. So yes, it's written here. You can see a beam is said to be loaded in pure bending if shear force is zero and bending moment is uniform throughout the span. Bending moment should be uniform. The shear force varies. Wrong option. Both shear force and bending moment are uniform. No, shear force should be zero and bending moment should be constant throughout the span of the beam. Both the shear force and bending moment are zero throughout the span. Wrong answer. The correct answer is option number three only. Fine, guys. So please take the screenshot here. I hope it is clear. No confusion is there. Fine, guys. Sure. Everyone done? Please put in the chat that you guys took the screenshot. Write in the chat the screenshot taken, sir. Okay. I'm not sure. I'm not getting any comments here. Great. So షియర్ ఫోర్స్ డయాగ్రామ్ బెండింగ్ మోమెంట్ డయాగ్రామ్ డ్రా చేయడం వస్తేనే ఈ చాప్టర్లో ఉన్న క్వశ్చన్ సాల్వ్ చేయగలుగుతాం అనమాట ఓకేనా సో ప్లీజ్ అండర్స్టాండ్ దట్ యూ నీడ్ టు బీ షూర్ అబౌట్ దట్ వన్ సో గ్రేట్ ఎవ్రీబడి క్లియర్ ఫైన్ నౌ లెట్స్ ప్రొసీడ్ with taking off for today. We'll meet in the next class. Most probably class will be on Sunday. I'll tell you. And on Sunday, I will be in Avid Center, Technogate. And if you guys, and I will be taking a physical class to some students there. So administration asked me to take some classes there. So if you are in Hyderabad and if you want to like listen any live class means in physical class in the center, you can come there. I'll be just giving an introductory physics class for the students who are coming there. Okay, everyone? Fine. Thank you so much, everybody. All the best. Let's meet in the next class, which definitely will be on Sunday. I mean to say physical class, but live class will be maybe on Monday or some other.